Hello everyone, welcome back to Code to Care, the AI ML video series that I'm doing. I mentioned at the first video that I was going to alternate between education, use cases, and then kind of the safety, ethics, validation, risks topic. So this is a use case topic today. So one of the use cases that I'm seeing take off in the market quite a bit is using AI to deal with the large volume of patient portal messages. So I wanted to use this video to describe that use case and what I'm seeing across customers. So let's just start with the problem. The problem is that there is a 30% increase in patient portal messages over the past few years. It used to be that there was a ratio of 1 message to 1 patient visit in health systems 5 years ago. But now, some studies say it's 6 to 1 between a message and a visit. So health systems, physicians, patients are starting to interact much more digitally with each other, which is creating this problem. There's some good things about that, but it's creating this particular problem. Another problem is that 4 to 10% of messages are urgent. So the patient really perhaps shouldn't have put that in the portal, but did anyway, and it's just sort of sitting there awaiting the health system responding to the message. And most health systems I've seen have like a 24-hour to 48-hour turnaround time commitment on messages. So an urgent message is a problem for everybody involved. And then lastly, in some portals, patients categorize the messages, like this is an appointment request, or refill, or a clinical question, or whatever. And some studies show that patients are only right 50% of the time. So the self-categorization process that we have patients do with most of our portals is really not accurate enough to drive the workflow effectively. So this is a problem that AI, I think, is well suited to solve. So I am seeing 3 kinds of solutions out there, or 3 different parts of the problem. So the first solution is urgency tagging. Okay, so many people are training models to automatically recognize whether a patient message is urgent or not. And then they may add a column to the inbox or prepend something to the subject of the message, and allows the contact center specialists and the people dealing with the inbox to sort and filter those messages to the top. Okay. Turns out a lot of urgent messages actually come in overnight or come in on the weekend. So some health systems have a workflow where first thing in the morning they come in, sort the work list, work all the urgents. First thing in the morning, deal with the patients, call them up, respond, those sorts of things, and then they can keep up for the rest of the day. So it's actually relatively easy to train these models to be very accurate. So most of the health systems that I've seen kind of present on this, they can get a 95% AUC on these models. And if you don't know what I mean by AUC, it's sort of like accuracy for a problem like this. So you can get them to be highly accurate. It adds this useful information to the inbox and allows the people processing the message to really get to the patients that need faster response. So that's one solution that I'm seeing out there. NYU Langone has presented. They've been using this for a couple years with a lot of great success. We're personally involved in another health system project on this. I've seen many health systems do presentations on this. So this is out there and is really kind of easy working use of AI for this problem. Second is proposing responses. So what this is, to state the obvious, is you have a message from a patient. You can propose you can use AI to propose a response back to the patient. And then there's a human in the loop that'll edit that response and put in some other information and then hit the send button. And this is really effective as well. And actually, there's some studies out there that show that messages that are written by chatbots or aided by chatbots are more empathetic than messages just written by humans. Now, I wouldn't argue that computers are more empathetic than humans, but empathy takes time. It takes time to sort of write a message that sort of acknowledges the patient problem, expresses kind of, empathy, I guess, in the process. And physicians are busy, office staff are busy. Sometimes you can't kind of include that empathy. And so what I've seen these responses do, or the best workflow, is it's sort of a sandwich. You have empathy at the beginning saying, sorry to hear about your problem, dear Mrs. Jones, thank you for contacting us, your care is important to us. And then you kind of have the meat of the message, with the human may write, the contact center specialist, and then you have sort of the ending of it. We hope that that answers your question. Feel free to contact us again. Here's our phone number. We hope you feel better soon. Those sorts of things. So empathy kind of takes time, but computers have lots of time, so they can easily kind of enhance the contact center specialist experience, make them more productive, and actually give a better response back to the patient. And these AI models, generative AI models, work pretty well on this task as well. And the third is workflow. Maybe I'll draw it here. Workflow. So you may imagine a message coming in. It's supposed to be an arrow coming into a queue, and then somebody's working the queue. But the reality is there might be a first line queue, and then for scheduling, it goes to this pool. For refills, it goes to this pool. For sick patients, it goes to this pool. This might have been misforwarded, and then it goes over here. And there's kind of a complicated process usually with delays in this. So it might sit in this first pool for 24 hours before somebody opens it and realizes, oh, this really should go, to the nursing pool, or should go to the office staff, or that sort of thing. So you have delays in this whole process. Well, you can also easily, and I've seen health systems do this, train machine learning models to automatically classify the message as to the eventual pool that it'll get into, and just put it straight into that pool. So this relieves a lot of time and delays in responding to the messages, but also reduces the workload for kind of everybody involved, especially in the beginning of the process, because it auto forwards the message. Is one way to think about this. And this classification of messages in these pooling concepts is also highly accurate. 95% kind of AUC. Type numbers, it's very effective at reducing work and lowering the time. So this is a great use of ML as well. So I would summarize then. Let me erase this. I'll just write notes. So one is these models are quite good. It's not hard to train accurate models to do urgency or to do workflow. In fact, in the workflow case, just to go back to there for a sec, you can train the model based on the actual behavior of the forwarding activity by the contact center team or the nursing team. So essentially, you can take the last few months, see where it eventually got forwarded to, and train a model to be very accurate on simulating that workflow. So you don't even have to label the data in that way. It's sort of auto-labeled by the past forwarding activity and the past pool assignment activity. So these are accurate models. I would say this is lower risk than other uses of AI. Because you've got a human in the loop in proposed responses. It's just sort of enhancing that experience, helping the productivity. And you're reading all the messages anyway, at least in all the workflow and projects that I've seen for patient portal messages. You read the messages anyway. You respond to every message anyway. It just helps you sort, filter, get it to the right person earlier, that sort of thing. So it ends up being a lower risk use of AI, which is important, of course, for absorption and that sort of thing. Customers that have done it have gotten very positive feedback from users. It has improved the numbers, so the turnaround time to patients, that sort of thing. But also the contact center specialists have been very positive on it. And then these are on-prem models, at least the first one and the third one. So that makes it easy. These are kind of smaller, they're still large language models, but they're smaller versions. They're actually, most have done with the evolution of BERT, if you know what I mean by that. But the very first transformer model that came out in 2018, there's a kind of fine-tuned versions of that with medical data. They almost always use that model. You can run it on a laptop, you can run it on a small server, that kind of thing. So you don't have risks of sending data out to cloud services or anything like that for those use cases. And then just patient experience, empathy, as well as kind of the contact center experience. This allows you to interact with your patients in a digital form, sort of take advantage of what consumers want today, and do it without sort of drowning in workload in your health system. So I hope that was interesting. I certainly see the patient portal message use case taking off out there, and I do think it's a good use of AI. Thanks, everyone.